Welcome to our STEM project presentation titled Alcohol Detection and Seatbelt Locking System using Arduino UNO. The project was completed under the course code of 22 UOC 205 at Dr. NGP Institute of Technology, Coimbatore, under the guidance of Dr. R. Moti, Assistant Professor of Department of Biomedical Engineering. Let's walk through how the safety-based embedded system works. Here, it's an outline of our presentation. We will begin with objective, move through the literature review, explain the steps involved in timeline, and then cover the block diagram, circuit connection, schematic diagram, flowchart, and finally our result and discussion. Reference also listed at the end of the project presentation. Objective of the project. The primary objective is to enhance the vehicle's safety by detecting the alcohol in driver's breath and preventing ignition if alcohol is found or if the seatbelt is not fastened. Especially, we use MQ3 alcohol sensor at the seatbelt switch connected to an Arduino UNO, which intellectually manages the motor control, buzzers and LCD alerts. Based on these inputs, literature review. We have studied several papers to understand the existing solution for alcohol detection and seatbelt compliance. Most existing systems focus on one of the two factors, but our integrated approach ensures the dual layer safety. For example, study have to touch sensor or IoT integration of alcohol detection, while others have explored seatbelt monitoring independently. Steps involved with the timeline. The timeline outlines the different phases of our project. First, we identify the components, then design the circuit and develop the Arduino codes. This was followed by simulation testing, debugging and demonstration. Each step was completed over a span of several weeks. Block diagram of a proposed system. The block diagram shows how the system works. The MQ3 sensor detects alcohol and sends analog data to the Arduino. The seatbelt switch acts as a digital input. The Arduino processes both inputs and decides whether the motor should run. A buzzer and LCD are used to alert the user of unsafe conditions. If safety conditions are met, a BJT activates the motor to run. Schematic diagram of the project. Here is the full schematic of our project. The MQ3 sensor sends the analog data to the Arduino A0 pin. The seatbelt switch moded as the push button connects to the digital pin D2. If alcohol is detected, the system immediately disables the motor, turn on the buzzer and display the alcohol detected on LCD. Transistors are used to safely switch the motor based on the Arduino output. Circuit connection of the project. MQ3 sensor VCC to 5V grounded to ground out to AO. Seatbelt button one side to GND and other to D2. Relay module VCC to 5V and into D8. Buzzer positive to D7, negative to GND. I2C LCD VCC to 5V, GND to GND, SDA to A4, SCL to A5. These conditions ensures the hardware can interact with the Arduino UNO for real-time processing. Flowchart representation of the project. This flowchart shows the decision-taking logic inside the Arduino. Read alcohol level from MQ3 sensor. Read seatbelt status from the button. If alcohol is present, buzzer turn on, motor stays off, warning is displayed. If alcohol is not detected but seatbelt is not fastened, motor stays off and display shows seatbelt warning. Only if both the conditions are satisfied, motor turns on and LCD displays safe to drive. The loop continues to check the condition constantly. Steps involved. Here we restate the main functional sequence. Sensor detection, read and analyze by Arduino, logical decision, controlling outputs like buzzer, motor and LCD. This slides re-emphasizes how these steps ensures are fully responsive and embedded safety system. Our result matches our expectation across three major scenarios. If alcohol is detected, engine remains off, buzzer on, LCD displays alcohol detected. If driver is sober but seatbelt is unfastened, engine off, LCD display please fasten seatbelt. If driver is sober and seatbelt is locked, motor starts, LCD shows safe to drive. These outcomes validate our system effectiveness in enforcing both conditions. References: we refer the numerous research papers and journal articles. These covered everything from touch-based alcohol sensor, automatic engine locking system to smart seatbelt detection system. This helps us to build a system that combines both detection and prevention measures. Now let us demonstrate the prototype. At first, when the seat button, which indicates the seat belt is locked, the motor starts running without any security alert. If the seat belt is removed, the motor stops and the system displays seat belt unbuckled. Next, when the alcohol is detected, especially ethanol, the motor stops immediately and the security alert is triggered and a message is displayed, alcohol detected, along with its level. When the alcohol level is above the threshold level, it shows warning, alcohol detected. When the alcohol level reduces, the system stops the alert. This can be placed in the steering to easily check the presence of alcohol in the driver's breath. Please leave in the comments. Thank you for watching.